Okay, so today we're going to get into naming and writing formulas with polyatomic ions. Um, Polyatomic ions. So if we break this word down, poly meaning many or more than one, atomic referring to atoms, and ions referring to charged particles. So what it is we have more than one atom making up the ion, more than one element. So here's a list of some of the more common ones. It's not an exhaustive list, but this is where we find things like acetate. This is where we find things like nitrate, nitrite, phosphate, sulfate, things like that. So, and if you notice, they have a similar formula, and then there's a little charge over here. So, for instance, sulfate is SO4, so one sulfur, four oxygens, and the whole charge is -2. So it's not all that different from what we've been doing as far as naming, not that different from naming normal ionic compounds. There's just a few little differences. So if I have a formula that might look like this, okay? So NaC2H3O2, okay? Well, you got to first identify that this is a polyatomic ion. Sodium, we know that Na is sodium. And then you got to know that C2H3O2 is a polyatomic ion, which is this one, and that is acetate. So we just name it sodium acetate. That's it. Pretty straightforward. Okay, we just give the metal its name and then give the polyatomic ion its name. That's it. Okay. So here's another one. FeCO3. Okay. Iron, remember iron is a transition metal, so if we have a transition metal, we still need to do the Roman numerals. So iron something, CO3 is carbonate. So iron something carbonate. How do I know what iron's charge is? Well, I know carbonate from my list. Carbonate is -2, so this whole thing is -2. So in order to balance it out, this has to be +2. So it would be iron 2 carbonate. Okay. Now, writing the formulas. So let's say we have calcium nitrate. Okay. I know from the periodic table calcium is Ca +2, and nitrate is down here. Nitrate is right there. Followed across, it is NO3 -1. So I write NO3 -1. Okay. Now from here we do our crisscross. Okay, so it's going to be Ca1, and then this is where it's a little different. NO3, I have two NO3s, right? So if I have two of a polyatomic ion, I'm going to put the polyatomic ion in parentheses and put a 2 on the outside, like so. Okay, I can't do, if I do it like this, NO3 2, okay, that looks like I have 32 oxygen, so that's not right. Okay. Also, we don't move this 3. Okay, do not do anything with that 3. That 3 has to stay with the oxygen, because if I change that 3 to something else, I no longer have nitrate. I have something else. If I change it to a 2, it's nitrite. If I do something else, it's just wrong. Okay, so make sure you keep that there. All right. So let's do another one. Let's say copper 2-phosphate. Okay, so copper, Cu, that 2 means it's +2. Phosphate, I look on my chart, and it is PO4 -3. Again, right there, phosphate, PO4 -3. Okay. And from here I crisscross, so it's Cu3, the 2 goes over there, the 3 goes over there, and PO4 in parentheses with a 2 on the outside. Okay. So you don't have to put the polyatomic ion in parentheses if you only have one of them. You can, it's just not necessarily it isn't necessary. So let's do one more. Lithium hydroxide. Lithium hydroxide. So Li is lithium +1. Hydroxide is OH -1. So since it's +1 and -1, they just become LiOH. And that's it. Again, very similar to what we've been doing. We're just adding those polyatomic ions, but you're treating them just like they're any other element. All right, let me know if you have any questions.